Hello, today we're going to be solving systems of inequalities. So inequalities have many solutions, so when we graph systems of inequalities, we're going to have sets that are going to be our solution set. Let's take a look at one inequality first. So with this first inequality, we're going to go ahead and we're going to solve for y. As a reminder, when we divide by a negative or when we multiply by a negative, you have to switch your sign. So this should become y is greater than 2x minus 5. We're going to go ahead and graph this in slope-intercept form. So we go down to -5 on our y-intercept, and we go a slope of 2. And this line is going to be a dotted or dashed line because it's just greater than and not equal to at all. So to figure out which side, we're going to go ahead and test a point. We're going to test 0, 0. I'm going to test it back in my original inequality, and that way if I forgot to switch my sign, I'll still be able to shade the right side. So if I plug in 0, 0, I get 0 is less than 5. That is a true statement, which means I shade the half with 0, 0. So in this solution set, anything that is shaded is going to be part of the solution set and it would satisfy the inequality. So to list 3 points, you can honestly pick any 3 points that are in the solution set, like -6, 0, or 0, 10, or -1, -3. All of those points work. You could not list any point on the line or any point in the unshaded region. So when we have more than one inequality on the same graph grid, the overlap is going to be our overall solution. So let's take a look at number 1. I'm going to go ahead and I'm going to graph y is less than 3. I'm going to graph it in blue. So y equals 3 is a horizontal line. Y is less than 3. Less than means we're going to shade the bottom, or you could plug in 0, 0 and get a true statement. For the next one, I'm going to go ahead and shade this one in green. We're going to solve for y. We get y is greater than or equal to -x plus 1. So I'm going to graph that using my slope and my y-intercept. And then this one would be a solid line because the or equal to is there. If you plug in 0, 0, 0 is greater than or equal to 1. That is not true. So we would go ahead and shade everything that doesn't have 0, 0 on that side. Now looking at this, it's a lot to look at. So right now we are looking for the overlap where blue and green are shaded together. So wherever that is going to be our overall solution set. So it should be everything in between those two lines in that one area. So you can use like a different color, you can darken it somehow, but you do need to identify that that area is the shaded region or your solution. Now, no matter how many inequalities you have, you're still looking for the overlap of all of the inequalities. So even with the next one, we're going to go ahead and look at all of these. We graph each of them individually, being very careful with your dotted or solid line. Now let's say accidentally you've graphed all of these and you realize like, hey, I made that a solid line and it was supposed to be dotted. I'm okay if you go ahead and recognize it here and say that's supposed to be dotted. It's much nicer than trying to erase everything. So that's okay if you need to do that. Okay. So we graph that one. It's a dotted line. We plug in 0, 0. It does not work. So we're going to shade the part without 0, 0. We're going to graph the next one. You plug in 0, 0, and it's true, so you shade the part with 0, 0. And now I'm going to use another color because we have a third one here. So it's going to be a vertical line through 2, and everything greater than 2 should be shaded, so that's everything to the right. So again, for this one, there's a lot to look at here. I'm going to use a dark highlighter. So you're going to look for where the red, blue, and green are all overlapping. So our bound here is at 2, and then everything over here. So this over here would be our solution. Okay, thank you very much. I hope this helped.